Now today's topic is about students t-test. Now student t-test is basically used to compare the population means of two different data sets, right? Girls here and boys here, right? So group of boys here and group of girls here. If I compare the weight or height, I would use a statistical test, that is t-test. And t-test is an inferential statistic, means we can draw conclusions out of this whether the means are equal or not, right? And then second part is whether these means are different, significantly different from each other, right? Or it is just by chance that there is some variation there, right? So this is basically about t-test. Now let us go to the brief history about this student t-test. Student t-test was described by an Englishman called Limujii Joy. He was graduating from Oxford, and there was a company called Guinness Brewery which was based in Dublin. Now Guinness has a policy to retain the best graduate from Oxford or Cambridge, and it was just by chance that he graduated from Oxford and he was absorbed here. Now Guinness Brewery was interested to produce the best wine, the best beers. Now best beer, for that they used different combinations of barley. Now he was assigned the duty of head brewer. Now as a head brewer, he had to distinguish between two different qualities of beers. Now the quality of beer was to be adjudged, and he stumbled upon a formula called as t-value. So he could determine the best beer using that statistical formula. Now Guinness had an interesting policy. He did not allow the author or discovery of that t-test to be published. So what we used is a pseudonym called as student, right? So that's why it was called as students t-test. It was published in Journal of Biometrica 1908, right? So this is about brief history of student t-test. Let us see the calculation portion of the student t-test. Now the calculation portion, suppose there are two groups, X and Y, right? I have two groups, X and Y. Say X is boys and we have girls, right, as Y. Now suppose I have to calculate the p-value. The p-value is calculated as mean of X minus mean of the second group Y, divide whole thing square root divided by standard deviation of X whole square divided by first sample size, that is the sample size of the X group, plus standard deviation of Y group whole square divided by N2. So these are the variables which we will be using for calculation of t-test values, right? Now let us start with the next portion of, after calculation we have to say whether it is significant or not. For that we do a hypothesis testing, right? We have a null hypothesis which states that there is no significant difference, right? The population means are same, so no difference of mean. That means population H0 and HA are equal, and we accept the null hypothesis. But there is other way around also, that there are differences of mean, right? That is, null hypothesis is not true, or alternative hypothesis is true, that the value lies in the rejection region, right? These are the rejection region, and in that case H0 not equal to HA, right? Null hypothesis is not equal to alternate hypothesis, right? Here we are giving two population mean graphs, one in green color and other is in red color, right? It could be X or Y, whatever, vice versa. Now here is the mean value and these are the variance, negative variance -1, -2, -3 and similarly 1, +1, +2, +3. Now for judging whether it is significant, it is very important to identify the critical value, and critical value if we set for this is around, if you see we have set around 2.7. So anything less than 2.7 would signify null hypothesis is accepted, or if it is greater, the calculated value is greater than 2.7, it will follow in the rejection region. So null hypothesis will be rejected and alternate hypothesis will be accepted, right? So this we can do for 95%, 99%. This is the p-test table, critical table. Now here we see the values. On the left hand side we have degree of freedom, on the top on most side it is the confidence interval. So we are interested in 0.05, that is 95% confidence interval, and the value corresponding, say suppose we have 20 number of participants in this sample, so the degree of freedom will be 19. For 19 degree of freedom at 0.05 value is 1.729. so that is how we judge the critical limit. Basically we will be doing t-test using student as an example, and we will record their weight using this weighing balance, right? So there are 13 boys and 10 girls. They are standing according to their height in the room. So one by one they will come and record their weight, right? So first participant, we will record the weight. Observe. Let us see the weight. 62 kilo. Observe. And next, Kavita. Kavita is 50, we record. Now onto the calculation board itself, you can see the number of observation. We have increased the number of participants by 1 for girls and boys who are recording. So number of boys were 14 and for girls it is 11. So the value, the mean value of boys weight is 61.86 and for girls it is 50.63. Similarly, we have calculated deviation from the mean and squared the deviation from the mean itself. So we find that the squared deviation is 1487.69 for the boys, and for girls itself is 138.64. So this is x minus x bar and y minus y bar. These values are there. Now onto the calculation portion. If you can see, in calculation portion we find the standard deviation for boys weight is 114.43 and for that girls is 138.64. so when we calculate, the calculated value comes around 0.21. now after t-test calculation we ask whether these are significant or not, right? So in first instance we state that there is no significant variation between means of girls and boys weight, so null hypothesis is true. The other way around can be also true, that is alternate hypothesis, that there is a significant variation between girls and boys weight. Now on to calculation of degree of freedom. Now total number of participants total number of record were 25. So degree of freedom will be number of observation minus 1, that is 24, n minus 1. Now T critical value at 95% confidence level at 24 degree of freedom is 2.064. Now this seems that T calculated is very much less than T critical value. So it is falling within the acceptable range, and hence there is no significant variation between the means, right? So that means null hypothesis remains true. Otherwise, the alternate hypothesis could have been accepted. Hopefully you understood this concept. Hello everyone, please like, share and subscribe my channel.